Imagine standing at the edge of space, where the vastness of the universe stretches out in every direction, and the Earth is a mere speck in the distance. Below you, the sun burns fiercely, a massive ball of plasma with temperatures so high they could instantly incinerate anything that dares to venture too close. Yet at this very moment, there is a tiny spacecraft, the size of a small car, braving the unimaginable heat, headed directly toward the sun. This spacecraft is not just orbiting around the sun. No, it's diving into its outermost atmosphere, something that no human-made object has ever done before. This is the story of the Parker Solar Probe, the probe that defied the odds and managed to venture closer to the sun than anything ever created by humanity. The mission to send a spacecraft directly into the sun's corona, the outermost layer of its atmosphere, began in August of 2018. It was a journey that captured the world's attention and stirred excitement within the scientific community. The Parker Solar Probe's goal was clear but audacious: to get closer to the sun than any probe before it, to study the solar phenomena that are not only fascinating but essential for understanding how the sun affects our planet. But this mission wasn't just about being close. It was about surviving the brutal conditions of space and the sun's extreme heat and radiation in order to gather crucial data. Before the Parker Solar Probe, humanity had only been able to observe the sun from a safe distance, protected by Earth's atmosphere, or from the safety of orbiting spacecraft. The heat and radiation surrounding the sun were simply too powerful to allow any spacecraft to venture too close without being destroyed. But the Parker Solar Probe was different. With its cutting-edge technology and innovative design, it would attempt what was once thought impossible: to enter the sun's corona and return with valuable information. But let's pause for a moment and think about the odds of this mission succeeding. The sun, a ball of fiery gas, burns at over 5,000 degrees Celsius at its surface, with temperatures soaring much higher in its atmosphere. To survive in such an extreme environment, the Parker Solar Probe had to withstand these unbearable conditions, an almost impossible feat. Yet in the face of this daunting challenge, scientists and engineers were determined to make it happen. The probe's success would not only answer some of the sun's deepest mysteries, but also teach us more about space weather, which can have profound impacts on technology here on Earth. To understand the significance of this mission, it's important to consider how much we still don't know about the sun. For centuries, scientists have tried to uncover the secrets of the sun's behavior: why its solar winds blow at such high speeds, why its magnetic field fluctuates so dramatically, and what causes its unpredictable bursts of energy in the form of solar flares and coronal mass ejections. These events, though fascinating, can have devastating effects on Earth, disrupting communication systems, GPS networks, and even power grids. Despite this knowledge, we still didn't know enough to predict when these solar storms might occur, or how they would affect our planet. That's where the Parker Solar Probe came in. By diving into the sun's atmosphere, this probe would provide data that could help scientists understand the inner workings of the sun and its impact on space weather. But for this to happen, the probe had to survive conditions that would destroy most machines in a matter of seconds. So how did scientists and engineers manage to design a spacecraft that could survive the scorching heat and intense radiation? The answer lies in the innovative heat shield that was created for the Parker Solar Probe. This heat shield, made of carbon composite materials, was designed to block over 99% of the sun's heat. This allowed the probe to remain cool enough to function even as it approached the sun's surface, which was more than 7 million kilometers away, 7 times closer than Mercury, the closest planet to the sun. But surviving the heat wasn't the only challenge. The Parker Solar Probe would also need to survive the intense radiation that could strip away electrons from atoms, potentially damaging the probe's sensitive instruments. To protect itself, the spacecraft was outfitted with a range of advanced technologies, including specialized sensors and a unique thermal protection system. To make the mission feasible, the Parker Solar Probe didn't just head straight for the sun. Instead, it followed a carefully planned trajectory, using Venus's gravity to slingshot itself closer to the sun with each orbit. This gravity assist from Venus would allow the spacecraft to gradually get closer to the sun, over the course of several years. Each time it completed an orbit, it would be able to gather more data while simultaneously testing the durability of its shield and instruments in one of the harshest environments known to science. In terms of speed, the Parker Solar Probe was no slouch. The spacecraft reached speeds of up to 700,000 kilometers per hour, making it the fastest human-made object ever created. At that speed, the probe could travel from Earth to the Moon in just under 2 hours. Yet despite this incredible speed, the Parker Solar Probe had to stay on course, carefully adjusting its path to avoid being overwhelmed by the sun's gravity or radiation. And even though the spacecraft was traveling at mind-boggling speeds, it wasn't just a matter of getting close to the sun. The real challenge was surviving the intense conditions within the sun's corona. The radiation levels were so high that if the spacecraft were unprotected, it would have been obliterated, almost immediately. Yet, the Parker Solar Probe's engineering team designed it to survive these extreme conditions by using advanced technologies and materials that could endure the intense heat and radiation for extended periods. The risks of the mission were undeniable, but the potential rewards were even greater. As the Parker Solar Probe gradually approached the Sun, it would collect data that could reveal new insights into solar phenomena that have long remained mysterious. These findings could change the way we understand the Sun and the impact of space weather on Earth, giving us the ability to predict solar storms and protect our technology from their effects. But at this point, the probe had only just begun its historic journey. The question still remained: would it survive the harsh conditions of the sun's corona? Could it gather meaningful data without being destroyed by the very forces it was sent to study? These questions loomed large as the Parker Solar Probe began its mission to the heart of our solar system. As the Parker Solar Probe approached the sun, the temperature soared. Imagine being in the middle of a furnace where the heat is so intense it could melt the strongest materials in seconds. But the Parker Solar Probe was no ordinary spacecraft. It was a masterpiece of engineering, built specifically to endure this extreme environment. The sun's corona, where the probe was heading, is a place where temperatures can soar to 2 million degrees Celsius. Yes, 2 million. To survive this, the Parker Solar Probe had to be equipped with one of the most advanced heat shields ever created. The shield is made of a material called carbon composite, designed to withstand temperatures higher than most Earth-made materials could ever survive. This heat shield, which is the size of a small car, acted like a giant umbrella protecting the spacecraft from the searing heat that would otherwise have turned it into a pile of ash. The shield itself was about 12.5 centimeters thick, just thick enough to block over 99% of the sun's heat. To put this in perspective, that's like standing in front of a blast furnace while only feeling the heat of a summer day. Its design was so advanced that it was able to reflect the sun's rays back into space, allowing the spacecraft's sensitive instruments to stay cool enough to operate. But the heat wasn't the only problem. The radiation surrounding the sun is so intense that even the slightest exposure could fry the electronics of any spacecraft. The Parker Solar Probe had to contend with radiation levels that would instantly destroy most modern electronics. The spacecraft's instruments, sensitive and precise, had to be shielded from this radiation at all costs. This was where the innovative design of the probe's components came into play. The probe's body was covered in an additional layer of protection known as the thermal blanket. This was a protective layer made from a material known as a high-tech aluminum-based fabric. This blanket helped to dissipate the excess heat, keeping the rest of the spacecraft's components at a manageable temperature. It was vital for the spacecraft to remain cool, not only to protect its instruments, but also to ensure the health of its solar panels, which provided all the power the probe needed for its journey. However, it wasn't just about surviving the heat and radiation. The Parker Solar Probe also had to deal with the sun's magnetic field, which is both powerful and unpredictable. The sun's magnetic field is one of the most complex and mysterious aspects of its behavior, and understanding how it works is one of the primary goals of the mission. The sun's magnetic field can affect everything from solar flares to coronal mass ejections, phenomena that can send massive bursts of solar particles hurtling toward Earth. In order to study these magnetic fields up close, The Parker Solar Probe carried a suite of specialized scientific instruments. These instruments included a suite of plasma detectors, magnetometers, and imaging systems, all designed to measure the various phenomena that occur in the Sun's atmosphere. These detectors and sensors had to be protected from the intense heat and radiation, which meant that every piece of equipment had to be carefully calibrated and tested before the probe was launched. The Parker Solar Probe's journey was not just about surviving these conditions, it was about learning from them. The data collected by the spacecraft was expected to yield groundbreaking insights into how the Sun's magnetic fields work and how they contribute to solar activity. This knowledge could change everything we know about solar winds, solar storms, and their potential impact on life on Earth. But even with the most advanced technology, it wasn't all smooth sailing. Every time the probe got closer to the Sun, it faced new challenges. The spacecraft's path was carefully planned to minimize risks, but there were still uncertainties. Would the probe's heat shield hold up under the intense solar radiation? Would the instruments be able to function in the extreme environment? Every successful orbit brought a new layer of excitement, and with each flyby, the team of scientists and engineers aboard the mission was one step closer to answering questions that had been unanswered for decades. The Parker Solar Probe's orbit around the Sun wasn't just about flying in a straight line. It followed a carefully calculated path, using Venus's gravity to slingshot itself closer to the Sun with each orbit. This gravity assist maneuver was essential for the mission's long-term success. Each time the spacecraft completed an orbit, it would get just a little bit closer to the Sun, getting closer to that elusive goal, to enter the Sun's corona and study it from the inside out. The first close flyby of the Sun came in November of 2018, and it was a historic moment. As the probe ventured closer to the Sun, the instruments began to collect data that had never been gathered before. The spacecraft's first close encounter showed just how much we still had to learn about the Sun's atmosphere. Scientists observed strange, unexpected phenomena in the solar wind, which could help explain why the Sun's corona is so much hotter than its surface. These early observations were just the beginning. With each successive flyby, the probe would continue to gather data that would challenge existing theories about the Sun. But there was still so much that could go wrong. The intense heat, the crushing radiation, the unpredictable magnetic fields, it was an environment that would destroy most spacecraft in an instant. Yet, the Parker Solar Probe continued its mission, undeterred by the extreme conditions. Each time it successfully made its way closer to the Sun, it proved that humanity had achieved something that once seemed impossible. The Parker Solar Probe's design wasn't just about surviving the conditions, it was about actively studying them. Each piece of equipment was built with a specific purpose in mind, and each was a crucial part of the puzzle. The instruments aboard the spacecraft would allow scientists to gather data on the Sun's magnetic fields, solar winds, and coronal mass ejections, providing insights that could help us understand solar phenomena in ways we never thought possible. As the Parker Solar Probe moved closer to its goal, it wasn't just about collecting data for the sake of science. The mission was driven by a desire to answer fundamental questions that could have a real-world impact. Solar storms, coronal mass ejections, and solar wind all have the potential to disrupt technology on Earth, and understanding how these phenomena work is crucial for preparing for their effects. The data collected by the Parker Solar Probe would help scientists predict solar activity and its impact on Earth's space weather, potentially saving lives and safeguarding our technological infrastructure. As the Parker Solar Probe ventured deeper into the Sun's corona, something extraordinary began to unfold. This was no ordinary mission. This was a front-row seat to one of the most violent, mysterious forces in the universe. For decades, scientists had been puzzled by the Sun's behavior, particularly its incredibly hot corona and the complex dynamics of solar winds. But as the Parker Solar Probe collected data, it began revealing some of the most unexpected and groundbreaking discoveries in the history of solar research. One of the first revelations came as the spacecraft entered the corona itself. The Sun's corona, which we had always observed from a safe distance, is far hotter than its surface. At first glance, this seemed paradoxical. The surface of the Sun, known as the photosphere, burns at around 5,000 degrees Celsius, but the corona is much hotter, at temperatures reaching upwards of 2 million degrees Celsius. For years, scientists were baffled as to how this could happen. How could the Sun's outer atmosphere be so much hotter than its surface? The Parker Solar Probe provided the first opportunity to explore this puzzle up close. As it made its way through the corona, the spacecraft's instruments began to measure the solar wind in ways never before possible. What they discovered shocked many scientists. The solar wind was moving at much higher speeds than previously thought. The wind, which is composed of charged particles like protons and electrons, was accelerating to speeds of up to 700,000 kilometers per hour, far faster than any model had predicted. This led scientists to rethink how the Sun's corona functions. One theory that had been suggested but never proven was that tiny, rapid bursts of energy, known as nanoflares, could be causing the corona to heat up. These small but intense bursts of energy, almost like invisible explosions, could be the key to understanding why the corona is so much hotter than the Sun's surface. The Parker Solar Probe's data didn't directly confirm the presence of nanoflares, but it did provide the first evidence that the Sun's magnetic fields and solar wind are far more dynamic than anyone realized. The spacecraft's observations pointed to the possibility that the Sun's magnetic fields could be reconnecting in complex ways, transferring energy to the corona and heating it to extreme temperatures. But it wasn't just the corona that was hiding secrets. The Parker Solar Probe was also making new discoveries about the Sun's magnetic field. The Sun's magnetic field is notoriously difficult to study from Earth as it's constantly changing and fluctuating. But with the Parker Solar Probe flying through the Sun's atmosphere, scientists could study the magnetic field in ways never before possible. The spacecraft's magnetometer began to map the Sun's magnetic field with extraordinary precision, revealing that the field behaves in highly dynamic and unpredictable ways. One of the most surprising findings was that the Sun's magnetic field is not as symmetrical as scientists once thought. Instead, the magnetic field appears to be twisted in complex patterns, creating intricate loops and filaments of energy. These twists and turns in the magnetic field help to explain many of the Sun's more violent phenomena, such as solar flares and coronal mass ejections, CMEs. By studying these twists in the field, scientists could begin to predict when and where these explosive events might occur, offering a glimpse into how solar activity affects the Earth's space weather. But it wasn't just the solar wind and magnetic fields that the Parker Solar Probe was revealing. The spacecraft was also gathering data on the Sun's plasma, ionized gas that makes up much of the Sun's atmosphere. The probe's instruments were able to measure the density, temperature, and speed of the plasma in real time, revealing that the solar wind is far more turbulent than we once believed. The turbulence of the solar wind can create shock waves that travel throughout the solar system, affecting everything from communication systems to satellites. Understanding these shock waves is crucial for predicting space weather events and protecting our technology. Another unexpected discovery was the way the solar wind interacts with the magnetic fields of the planets in our solar system. The Parker Solar Probe's close proximity to the Sun allowed scientists to observe the way the solar wind influences planetary magnetic fields in real time. These interactions are important not just for understanding space weather, but for understanding how solar radiation can affect the habitability of planets. For instance, the interaction between the solar wind and Mars's weak magnetic field could provide insights into why the red planet lost its atmosphere millions of years ago. Similarly, the probe's data could help us understand how the Sun's energy impacts the habitability of exoplanets around distant stars. Perhaps the most exciting aspect of these discoveries is how they can help us prepare for future solar storms. We know that solar flares and CMEs can have serious consequences for Earth. A large solar storm could damage satellites, disrupt GPS systems, and even cause power outages on a global scale. By studying the data collected by the Parker Solar Probe, scientists hope to develop better models for predicting solar storms and their effects on Earth. This knowledge could one day help us develop more resilient technologies and protect critical infrastructure from the potentially catastrophic impact of space weather. The data returned by the Parker Solar Probe continues to challenge existing models of solar behavior. Each new flyby brings more insights into how the sun works, and each new discovery forces scientists to rethink what they thought they knew about our closest star. The probe has already begun to change the way we understand the sun, and as the mission continues, we can expect even more surprises. But what does this all mean for the future of space exploration? As we continue to push the boundaries of what's possible, the Parker Solar Probe serves as a testament to the power of human ingenuity and curiosity. Its discoveries are not just reshaping our understanding of the sun, they're opening new doors for future missions. With this newfound knowledge, we may one day be able to venture even closer to the sun or other stars, unlocking more mysteries about the forces that govern the cosmos. Moreover, the Parker Solar Probe's mission is just the beginning of a new era of solar exploration. The insights it provides could lead to new technologies and innovations in space travel, space weather prediction, and even planetary defense. For example, understanding how solar winds affect planets might help us design spacecraft that can better protect themselves from the intense radiation of distant stars, or it could inform strategies for terraforming other planets. As the Parker Solar Probe continues its journey, it is not just charting the sun's mysteries, it's charting the future of space exploration. The Parker Solar Probe's journey isn't just changing the way we understand the sun. Its discoveries are reshaping the future of space exploration and technology. This mission has already yielded breakthroughs that will influence everything from our ability to predict space weather to the very way we design spacecraft for future missions to distant stars. But the impact of this mission goes far beyond just academic research. The knowledge and technologies being developed through the Parker Solar Probe are laying the groundwork for humanity's next big leap into the cosmos. One of the most immediate and practical impacts of the Parker Solar Probe's mission is its potential to revolutionize our ability to predict and respond to space weather. Solar flares and coronal mass ejections, CMEs, are powerful bursts of solar radiation and charged particles that can affect everything from GPS signals to satellite communication systems. A large solar storm, if it were to hit Earth, could cause widespread power outages, disrupt communication networks, and even damage satellites in orbit. By studying the sun's magnetic fields, solar winds, and the behavior of plasma in the sun's corona, the Parker Solar Probe is providing crucial data that will help scientists develop better models for predicting space weather events. This knowledge is already being used to improve space weather forecasting models. For instance, by understanding how the sun's magnetic fields twist and reconnect, scientists can more accurately predict when and where solar flares or CMEs might occur. With this information, we could have more advanced warning systems in place to protect satellites and communication systems. This predictive capability could also allow for better preparedness when it comes to shielding astronauts aboard the International Space Station, ISS, or other future space habitats from dangerous solar radiation. But the impact of the Parker Solar Probe doesn't stop at Earth. As we look beyond our own planet and towards other worlds, this mission has profound implications for our understanding of the broader cosmos. The data collected by the spacecraft is helping to unlock the mysteries of other stars, and it's providing insights that will help us answer some of the most fundamental questions about the universe. For example, understanding the sun's magnetic field and solar wind is helping scientists refine models of how stars interact with their surrounding environments. This knowledge could one day help us study distant exoplanets, determining how solar activity influences their atmospheres and whether they could be habitable. In fact, the mission has implications for the search for life beyond our solar system. The sun's solar wind, coronal mass ejections, and radiation have played a major role in shaping the habitability of our own planet. But how does the solar activity of other stars influence the potential for life on planets orbiting them? The insights gathered by the Parker Solar Probe could help answer this question, giving us a better understanding of how solar flares and stellar winds affect the potential for life on exoplanets. In the future, this knowledge could guide the search for habitable planets around other stars, as we look for worlds where the conditions are right for life to thrive. On a broader scale, the Parker Solar Probe is pushing the boundaries of what's possible in space exploration. The spacecraft's ability to survive the extreme conditions of the Sun's corona and return invaluable data is a testament to the remarkable advancements in engineering and technology that have been made over the last few decades. The development of the heat shield, the thermal protection system, and the spacecraft's innovative instruments have set a new standard for future missions to the most hostile environments in the solar system. These advancements will not only help future solar missions, but they could also inform the design of spacecraft that can venture into even more extreme environments, such as the surface of Venus, the outer reaches of the solar system, or even interstellar space. The Parker Solar Probe's engineering feats don't stop at its heat shield and protective blankets. The spacecraft's ability to use gravity assists from Venus to get closer and closer to the Sun is a brilliant example of how we can use existing physics to make space exploration more efficient. In the future, this kind of orbital maneuvering could be used to help spacecraft reach distant stars or other planets in ways that are more cost-effective and energy-efficient than traditional rocket propulsion methods. The success of the Parker Solar Probe proves that we are just scratching the surface of what's possible when it comes to using gravity assists and other innovative propulsion techniques. Furthermore, the mission's impact extends to the future of space exploration technology as a whole. The Parker Solar Probe is providing engineers with invaluable data on how to protect spacecraft from extreme radiation, heat, and other dangers that exist in the harsh environments of space. The materials and technologies developed for this mission could one day be used to design more durable spacecraft, space habitats, and satellites for future missions to Mars, the outer planets, or even asteroids. This knowledge is crucial as we look to build the infrastructure necessary for long-term human presence in space. And let's not forget the scientific and philosophical implications of this mission. The Parker Solar Probe has brought us closer to answering some of the most fundamental questions about the nature of the Sun, the birth and death of stars, and the origins of the solar system itself. Understanding the Sun's magnetic fields and solar winds gives us a clearer picture of how our star interacts with the planets and how it has shaped the development of life on Earth. But there's an even bigger question that this mission touches on: what does the study of the Sun and stars teach us about the nature of the universe itself? By peering into the heart of our star, the Parker Solar Probe offers us a glimpse into the very processes that drive the universe, and in doing so, it reminds us just how much we still have to learn. This mission is about far more than just scientific curiosity. It's about pushing the limits of what humanity can achieve. As the Parker Solar Probe continues its journey, it's becoming a symbol of human ingenuity, determination, and the unyielding quest to understand the universe. With each new discovery, the spacecraft is paving the way for a future where space exploration becomes a routine part of life, where we can study distant stars, travel to new worlds, and maybe one day even unlock the secrets of interstellar travel. As the Parker Solar Probe continues its historic mission, we're left with a powerful reminder. The road to the stars is not without its challenges, but it is full of untold discoveries, breakthroughs, and possibilities. The impact of this mission will be felt for generations to come, as it helps us chart a course for future missions that will take humanity deeper into space than ever before. The discoveries made by the Parker Solar Probe are just the beginning. Who knows what we'll learn next? One thing's for sure, the journey to the heart of the Sun is far from over. So as we wrap up today's exploration, ask yourself, what will the future of solar exploration hold? What new technologies, discoveries, and missions will we witness in the next few decades? The answers are out there, waiting for us to find them. And if you're as excited about this new era of space exploration as we are, let us know what you think in the comments. Share your thoughts, theories, and predictions. If you enjoyed this deep dive into the Parker Solar Probe's historic mission, don't forget to like and share this video. Let's spread the wonder of the universe far and wide.